Welcome to the Survival Historian, where the grit of human endurance meets the forgotten wisdom of our ancestors. Today, we're stepping into the shadowed workshops of medieval Europe, where the ring of axes and the rasp of saws echoed through timber-scented air. Here, in an age we wrongly call primitive, master craftsmen wielded knowledge so profound that it challenges everything modern engineering assumes about strength, durability, and the very nature of construction itself. Forget the gleaming steel of our contemporary world. The real story of medieval supremacy was written in grain and not in living timber that breathed, flexed, and endured. This is the untold saga of wood's dominion over an age of supposed iron. We've been fed a compelling lie by our steel-obsessed civilization. When we imagine medieval engineering, our minds conjure stone fortresses and iron-clad warriors, as if these materials alone carried civilization forward. But walk into any surviving medieval structure and look up. What towers above you, spanning impossible distances and bearing crushing weight for 7, 8, even 9 centuries? Timber. The truth is that wood formed the skeleton of medieval Europe. While stone provided impressive facades and defensive walls, it was wood that created the vast interior spaces where life actually happened, where communities gathered, where commerce thrived, where prayers ascended through soaring cathedral roofs that seemed to touch heaven itself. Our modern bias toward metal has blinded us to a fundamental historical reality. Iron in the Middle Ages was precious, difficult to produce in quantity, and rarely suitable for the large-scale structural applications we associate with steel today. Medieval builders understood something we've forgotten in our rush toward industrial materials: that a living, breathing substance like timber, when properly understood and manipulated, could outperform the rigid, unforgiving nature of metal. They didn't choose wood because they lacked alternatives. They chose it because they recognized its superiority for their purposes, developing techniques so sophisticated that contemporary engineers study them with genuine humility. The medieval carpenter approached timber with the insight of a surgeon studying anatomy. They understood that wood wasn't simply a uniform building block, but a complex directional material whose strength varied dramatically depending on how you cut it, oriented it, and stressed it. This anisotropic nature, which modern builders often view as a limitation, became their greatest advantage. By selecting specific grain, orientations, and wood types for precise applications, they could channel forces exactly where they needed them, creating structures that responded to stress like living organisms rather than rigid machines. At the heart of this mastery lay joinery techniques that seem almost impossibly clever. The mortise and tenon joint, where a precisely carved projection slides into a matching socket, created connections that grew stronger under load rather than weaker. As compression forces bore down, the joint locked more tightly, turning weight into structural advantage. Dovetail joints, with their interlocking wedge shapes, prevented separation even under severe pulling forces. Scarf joints allowed builders to extend timber lengths indefinitely, creating continuous beams from multiple pieces that functioned as single, unbroken elements. Each joint was secured not with metal nails, which would rust, loosen, and split the wood as it swelled and contracted with seasonal moisture changes, but with wooden pegs called tree nails that moved with the timber, maintaining integrity through centuries of environmental stress. Perhaps most remarkably, many structures were built using green wood, timber fresh from the forest, still heavy with sap and moisture. This wasn't ignorance, but calculated brilliance. As the wood dried in place over months and years, it shrank, causing the joints to grip tighter and tighter. The structure essentially assembled itself into a self-tensioning framework that became stronger with age, the exact opposite of modern construction that typically weakens over time. Stand beneath the hammer-beam roof of Westminster Hall in London and, well, you're witnessing an engineering miracle. Completed in 1399, this roof spans more than 68 feet without a single supporting pillar interrupting the space below. The hammer-beam design, with its protruding brackets and complex web of timbers, redistributes the ceiling's massive weight outward and downward along the walls, creating what really appears to be a wooden sky suspended by medieval sorcery. 6 centuries later, those oak timbers still bear their burden without complaint, having survived fires, bombs, and the simple grinding weight of time. Cathedral roofs across Europe tell similar stories. The wooden frameworks supporting these structures often span distances that would challenge modern builders equipped with computer modeling and industrial materials. These weren't rigid, brittle structures, but dynamic ones designed to move. Medieval builders understood that timber needed to flex, to respond to wind loads and settling foundations, to breathe with humidity changes. They created frames that could twist slightly, distribute unexpected stresses, and recover their shape, behaving less like buildings and more like ships at sea, riding out storms through calculated flexibility rather than stubborn resistance. Archaeological evidence continually astonishes researchers. Wooden structures survive in waterlogged sites, in preserved roof spaces, in the hidden cores of later stone buildings, revealing engineering sophistication that, honestly, contradicts every assumption about medieval technological primitiveness. Carbon dating and dendrochronology, which reads tree rings like historical documents, proved that these timber frameworks performed flawlessly for longer than most modern steel frame buildings have even existed. Behind these achievements stood communities of craftsmen whose knowledge represented generations of accumulated wisdom. Medieval carpenter guilds guarded techniques passed from master to apprentice through years of training that began in boyhood and continued into middle age. These men could read timber like we read text, identifying species by smell and touch, predicting how individual pieces would behave under stress, selecting trees in the forest years before they'd be needed for construction. They understood which oaks grew in which soils produced the straightest grain, how trees from valley bottoms differed from hillside specimens, when to fell timber for maximum strength. Their tools, all hand-powered, achieved precision that modern power tools struggle to match. Broad axes shaped massive beams to tolerances measured in fractions of inches. Augers bored holes perfectly perpendicular through 2-foot-thick timbers. Hand saws cut joints so precise that completed connections needed no caulking or filling. This wasn't primitive technology, but appropriate technology. Tools perfectly matched to their materials and purposes, wielded by hands that had shaped 10,000 joints before attempting the critical connections in a cathedral roof. These woodworkers shaped medieval society in ways that extended far beyond construction. They managed forests sustainably, ensuring renewable timber supplies. They formed powerful economic forces, their guilds wielding political influence and setting quality standards. The survival skills embedded in their craft, the ability to read natural materials and work with rather than against natural properties, represents precisely the kind of adaptive intelligence that separates those who endure from those who merely exist. Today, as we grapple with sustainability challenges and the environmental cost of steel and concrete production, architects and engineers are rediscovering what medieval builders knew instinctively. Cross-laminated timber and massed timber construction methods now enable wooden skyscrapers, applying medieval joinery principles with modern manufacturing precision. These structures combine wood's natural carbon sequestering properties with structural performance that meets or exceeds conventional materials, proving that the old ways weren't primitive but pioneering. The legacy of medieval timber engineering teaches us that survival, whether of individuals or civilizations, depends on understanding and working with the materials and conditions available, rather than imposing industrial standardization regardless of context. Those carpenters survived and thrived because they observed, adapted, and refined their craft across generations, creating structures that literally outlasted empires. Their genius lay not in brute force, but in elegant solutions, not in fighting nature, but in channeling it, not in rigid permanence, but in resilient flexibility. When you encounter a medieval building, look past the stone to find the hidden timber bones that give it life. Feel the weight of those oaken beams, seasoned by centuries. Remember that these structures endure not despite being built of wood, but because of it. Monuments to a forgotten supremacy of grain over metal, flexibility over rigidity, ancient wisdom over modern assumption. If this journey into forgotten engineering brilliance has opened your eyes to the resilience and ingenuity of our ancestors, hit that like button and share this video with anyone who appreciates how survival and history intertwine. Subscribe to The Survival Historian for more deep dives into the techniques, knowledge, and raw determination that allowed our predecessors not just to survive, but to create wonders we still can't fully replicate. The past isn't primitive. It's a blueprint for endurance we ignore at our peril. Until next time, keep learning, keep adapting, and keep the old wisdom alive.